Alright guys, welcome back to the day 2 solving systems by graphing. We only have 2 slides, so this video should be on the quicker side, and what I want to focus on today is being able to name if something is one solution, infinite many solutions, or no solution without having to take the time to create a graph. Or if we do, we could create a very quick sketch without much detail. So I want to go over the information that we know from the last set of notes when it comes to one solution, infinite many solutions, and no solution. The first thing I want to look at is a quick sketch. If I had something that's one solution, I would have 2 lines, and they would just cross somewhere. And wherever they cross, we were circling this in green every time, would be our answer. So with this, guys, I don't have any exact numbers on here, but what I want you to realize is that the slopes have to be different to make this work. Also, our y-intercepts will be different. In some cases, they can be the same, but most times they're not. So we can put sometimes the same. And then the solution on this is considered a one solution. So we can just literally put the number 1 there. Going over to infinite many solutions, this is where we have 2 lines and they end up being identical. So they're right on top of each other. I'm going to draw the one with shorter arrows so it's a little bit easier to tell what's going on. And when this happens, our slopes are exactly the same. Also, our y-intercepts are exactly the same. And when this happens, guys, we have infinite many solutions. Remember, I said in the notes yesterday, I will be abbreviating this IMS from here on out. Feel free to do the same so we don't have to write out that huge long answer. No solution is when we have 2 lines that run parallel like train tracks. They are never going to touch as far as they go. When this happens, our slopes are the same, and the y-intercepts are always different. When this happens, it makes us have no solution. So what we need to pay attention to right now is looking at the slopes. If you have slopes that are different, all right, so we're over here, slopes that are different, it has to be a one solution problem. There's no way it could be infinite many solutions or no solution, okay? If we have the y-intercepts, if we look at these, if we notice that the y-intercepts are the same, it could be one solution, it could be infinite many solutions. If we notice the y-intercepts are different, it could be one solution, it could be no solution. So on that, you would need more information. You'd need a slope and a y-intercept to figure out what's going on. All right, so let's look at some examples real quick. Use this information to figure out what type of answer we have, one solution, no solution, or infinite many solutions without making any graphs. So when we look at problem A here, we can see that the slopes are different. And we can see that the y-intercepts are the same. So just with this information, without creating a graph, let's look at that combination, different and the same. And when we go back here and we look at those combinations, the only combination that has different slopes and the same y-intercept is a one solution problem. So we can flip back over here and we could say that this has to be one solution. Now we don't know exactly what the solution is. I don't have an exact x equals y equals, but I know that there's only going to be one answer if I did graph these two y equals mx plus b's. Moving over to b here, guys, we have to do a little bit of work to save us some time. I've already done this. This is going to be y equals negative 2/3 x, and then it will be plus 2. And then this bottom one I'll do in a separate color. We get y equals negative 2/3 x as well, plus 2. So when we look at these, we should notice slopes are the same. Also, the y-intercepts are the same. So which combination has the same on both? So we go back and we can see the only one that has the same on both is infinite many solutions here in the middle. So even though we have not graphed this yet, we can tell that this answer is going to be infinite many solutions. So I don't have a third example of no solution on there, guys, but if I did, you would just need to look at the combination. It would be a combination where the slopes were the same, the y-intercepts were different, and then you would have known that is no solution. So guys, that wraps up our notes. Quick notes for today. We'll be able to finish the day 2 worksheet, and then we'll be grading that. If you have any questions, make sure you're working with somebody else or asking me some questions to get everything figured out in class.